electric field lines. Okay, next topic, this one, electric field lines. Now see, electric field, that is the vector quantity. So we can represent electric field with the help of vectors, as we draw the vectors, and we can say electric field lines, that is nothing but the pictorial representation of electric field. So if we represent electric field with the help of vectors, which we represent graphically, then we can get idea how the electric field is prevailing, in which manner it is prevailing in the surrounding space of the source charge. See here, suppose we think about the positive charge, then now we have the equation for electric field, that is kq upon r square. So in the surrounding space, at any point, if the unit positive charge is placed, then the force will be repulsive. So electric field will be radially outward. But electric field decreases as 1 upon r square, because it proportional to 1 upon r square. So as we move away from the source charge, the field intensity, means magnitude of the electric field, that is called field intensity, that decreases. So here these vectors are represented with small length, because the magnitude of the quantity that proportional to the length of the vector, in that manner we prepare the vectors. Similarly, if we think about the electric field of negative charge, then we can represent it with vectors as shown in this figure. All these vectors are towards the negative charge, so that is radially inward. Okay, now if we think about the electric field of dipole, di means two poles, polarity, positive, negative. Okay, then the electric field line will come out from the positive charge and will enter to the negative charge. In that way, the electric field that prevails. For two positive charges, the electric field that will be as shown in this particular figure. Clear to all of you? Now, the proportionality of electric field on the distance. To understand this thing here, let's consider one point charge, capital Q. Now, its electric field that is prevailing in the surrounding of it in outward direction. Okay. Now, suppose we consider 2 points P1 and P2 in the electric field, and at the position of P1, here we consider a small surface delta S1, and at point P2 we consider another surface delta S2, and here the surfaces under consideration are such that the number of field lines passing through both the surfaces, that is same one. That is same one. Now, if we think about the angle subtended by these surfaces at the position of Q, that will be the solid angle, because electric field that prevails in all the directions. Okay, so here, as per definition of solid angle that is equal to surface upon radius square. It implies that radius means we have to take the distance from Q to P1 and Q to P2, means distance of that surface from the position of this source charge. So we can write now delta S, that is equal to delta omega into R square. Now delta S1 this surface delta S1, that is equal to delta omega into, suppose the distance between Q and P1, that is R1. So we can write delta S1, that is delta omega into R1 square. Delta omega is same one for both the surfaces. So we can write delta S2, that is equal to delta omega into R2 square. Now, another definition of electric field that we can give like this: the total number of field lines passing through unit area at a particular point perpendicular to that area, that is also called electric field intensity. So if we think about any point and there we take the unit surface area, and then after if we calculate the total number of field lines passing through it normally, then that is equal to the electric field intensity at that particular point. So as per that definition here, if we take the electric field intensity at point P1, then we can write E1, that is equal to, now we have to take the number of field lines passing through unit area at point P1 perpendicular to it. Here arbitrarily we consider, suppose total number of field lines passing through these surfaces under consideration, that is n perpendicular to these surfaces. So if total number of field lines passing through this delta S1 and delta S2 perpendicular to it, that is n, therefore the number of field lines passing through unit area is how much? So we can write now as per that, number of field lines passing through unit area at P1, that is n upon delta S1, but as per definition that is electric field intensity at P1. So E1 equal to n upon delta S1. Similarly at P2, the electric field intensity E2, that is n upon delta S2. Clear? So E1, that is n. Now substitute the value of delta S1 and delta S2 here, delta omega into R1 square. E2, that is n upon delta omega R2 square. But see here, n and delta omega, that is constant one. So we can write E1 proportional to 1 upon R1 square, E2 proportional to 1 upon R2 square. It implies that the electric field intensity, means magnitude of the electric field, inversely proportional to the square of distance from the source charge. Clear? And in equation also, E, that is KQ upon R square, we discussed the same thing, and here that is justified one. Clear to all of you?